More sense that way. All right, so my name is Nickolaus Saint. I work with professional services at Globus, joint with Argonne. Today let's talk about Gladier automation with funcX and flows. So what is Gladier? Well, it stands for, it's an acronym, the Globus Architecture for Data Intensive Experimental Research. But in a nutshell, really what Gladier is, it combines Globus flows with funcX. So it takes the automation of Globus flows and allows you to run your funcX functions within them. Really quickly, Globus flows themselves are Globus flows as a service, a Globus service built on Amazon state machines, where each state is a call to a different Globus service. So that really allows you to easily chain events in order. For our purposes, it allows you to do that initial transfer to get data into your HPC environment. Then you can run your analysis step, you can run your funcX functions, and really you can keep going afterwards if you want to do like a transfer back to your a publication endpoint if you want to catalog. We do this as part of our extended flows. Sure, the sky's the limit to how far you want to automate, but it really gives us this, this great way to add an automation pipeline, including our funcX functions and also to process our data. So Gladier sits on top of this. It accelerates some development by automating some of the common tasks associated with both funcX and flows. When we start to add stuff around our funcX functions and build automation around them, some things like registering funcX functions gets a bit more difficult just because it's adding more steps. So Gladier automates this by automatically detecting when funcX functions change and re-registering them. And the same thing in flow composition. So it's especially when you're going through and writing these automation flows, it won't work perfectly at first. You'll need to take steps out and put steps in. So Gladier really helps with flow composition and stringing these things together when you need them and building these things out rapidly. So what do one of these flows look like? Let me show you. Here's an automation pipeline for one of the projects we've been working on. This is serial crystallography at Argonne at the APS. You can see the flow where it starts at the top and wraps around. This particular flow, we run it during live capture. So we're capturing data at the APS. And when we get enough data, we go ahead and start one of the flows. We keep starting flows until we finish. First part of the flow is we have enough data, we transfer it into our HPC environment, Theta or Polaris. And immediately after that, we start running our funcX functions as part of the flow. So the first thing we do is run dials, we run analysis. We run a few of these funcX functions in series. So next thing we do is write some make some plots to visualize what's going on. We pull some metadata out of the results we got and catalog those into Globus Search. Globus Search is another
we can't hear you.
Globus service we can use to, we build portals around it. So we can really easily visualize the results from the data sets we've got. And this is all happening during data capture. So you can imagine this flow running several times a minute. We can watch this flow, we can watch the results from data capture update in real time. We can keep refreshing the page, sort of a small screenshot on the portal there on the bottom left. But we can see in real time, how is this chip doing? Is it doing well? Is it doing poorly? Do we have enough to solve the structure? That last part of the flow is really the thing, it's the end goal. We want to, after we solve the structure, we're done. So we keep collecting data until we can solve the structure. And once we do, we can stop. And that's a really nice way to inform data capture, because sometimes we get terrible samples and we just need to keep running them. Other times we get great samples. And if we can solve the structure after a couple of those, we can just stop and either go home for the day or put in new proteins if it's, we have more than one. So it's a great way to inform data capture in that way. All right, so that's one of the flows we're running. Let's get some of our other projects and how many we're running over time. So doing this for a couple of years now, we've been growing the number of flows we've been running each quarter. We don't have data for this year, but I believe last month we ran upwards of 20K. So we're continuously increasing this number quarter by quarter, year by year. And we hope to continue doing so. So that's an overview of some of the flows we've run before, but I haven't really showed you any of the code yet. So let's jump in and see what does it look like writing code in Gladier, composing these flows in Gladier. So the base Gladier class is really simple by design. It's this thing at the top. We define a class, subclass our Gladier base clients, and define one static variable called Gladier tools. This is just a list of tools. Each Gladier tool contains both state information, and if it has funcX functions associated with it, it tracks those as well. Tools can have an arbitrary number of these states. Really, at this point, we just want to know basically what we're running and the order we want to run them in. So our first state there in this example is transfer. It's really simple, behind the scenes, that's just one state. Dials is our funcX function. That's just another one state which runs our funcX function, and the dials stills tool there references the funcX function on it. Below we have the input for each of these. The tools also track required input that each tool needs. Transfer requires the source endpoint, source paths. Dials, of course, it requires a funcX endpoint. Most tools would require extra parameters as well. Just for simplicity, we left those off. One thing you'll notice that's missing is a funcX function UUID. How is this flow going to run if it doesn't have a funcX function UUID? Well, Gladier does that automatically for you. So you can imagine if you expand the number of tools you have here, if you have 7 or 8 funcX functions that you're running at a time, copying and pasting new UIDs for each of those, remembering which one you did gets very tedious after a while, and humans are really bad at remembering which thing they changed. So Gladier does this automatically. Anytime you change a function associated with one of these tools, Gladier will go through and checks on it. And if the checksum differs, it will automatically re-register it for you and include it as part of the flow. So when you get to the bottom here, when you run that run method, Gladier is going through and it's checking the tools, and it's composing a flow around the tools you have listed there, and it's double checking your funcX function definitions, and it's re-registering any of those if any of those are out of date. So it makes that guarantee that when you're doing a run there, everything's up to date, and everything is good to go. Everything's good to run. So that's Gladier in a nutshell. Anyone has any questions, welcome to answer them. You can also go to our Read the Docs site if you want to give this a look yourself, deploy some flows, and run some Globus automation pipelines. Thank you so much. Happy to take questions.
Questions, team? I'll leave it a question. Tyler.
Hi, Nick. It's Tyler. One question I have is, so the flow you showed is kind of like an A to Z straight line. Is there a way to like fork based on like an output at some point? Like, let's say
that's a good question.
Yeah.
Conditional.
So let me go back to that slide. You can't do that with current, like that's a feature we want to add very soon, where you can fork arbitrarily within tools or to other tools. Right now, you can do that by adding your own flow definition and going beyond the inbuilt Gladier flow composition itself. That's a perfectly acceptable way to do that as well. Yeah, we want to add that in as a like flow branching within tools itself as a feature within Gladier. We'll be adding that pretty soon, actually, in the next couple of weeks.
Awesome.
Other questions? Matthew Bufflin.
Similarly to Tyler, is there any kind of high-level steering, almost like a parcel-esque DAG management, where if you have parts of the flow that can be spun off that are not dependent on other results, that those can just go off and do what they need to do, and then the ones that do need to wait for previous tasks to complete will wait, presumably?
That's a good question. That might be more dependent on how you structure your flow. I believe it's possible to start flows within other flows. So that might be one way you could solve that problem. And I don't see any reason why you couldn't do that in Gladier as well. I think that answers your question, hopefully.
I think flows themselves are actions that can be embedded in other flows. So
Another semi-related, I'm sorry, Ben. Another semi-related one. Can I specify more than one funcX endpoint? Or, can I specify a subset of a flow on one and a subset of a flow on another?
Yes. So we have only one here for simplicity. On our HPC environments like Data or Polaris, we almost always have two. One that is running on the head nodes that has internet access, and another is doing computation tasks. And you can add arbitrarily however many you want. And for your tools too, that's one of the generate flow definition decorator up there right now isn't passing parameters, but that's one of the parameters you can add for your funcX functions to say, hey, I want to run this on this particular funcX endpoint. And so you can split up your workloads that way if you want to.
Thank you.
So, Ben Galuski here. So what do you see as your value add on top of Automate? Like, why wouldn't I just use Automate directly for doing this?
it's a good question.
Sure. So I guess it's kind of the point of we started that first. And you can just add your funcX functions to your flow, but function ID management becomes difficult over time. In addition to if you imagine you have like a 10-step flow, and the 7th step in your flow, one of the last states fails. If you want to debug that flow, you have to do a good amount of work to split apart, redeploy your flow to either make those first 7 steps not run in order to debug your last state, or there's a lot of manual stuff you'd have to do otherwise to do this. And with Gladier, it makes development of those tasks very quick. So it's automating the funcX IDs, which would be a manual step. It automates it really helps with flow composition. So it makes building those really quick if you want to add or remove steps.
Yes, I think the two things are the Python interface. So Gladier gives you a pure Python interface on top of the funcX API, not funcX, the flows API and representation.
Mm-hmm.
And then the second thing is that abstraction of being able to sync the flow and the functions together, being able to keep them in step with each other. I think that's what Ryan's going to give us a thought.
It standardizes where all of your outputs go under different branches, so we can automatically extract timing from everything. Very nice plots.
And this is using the funcX action provider, isn't it?
It is, yeah.
Yeah.
So it's probably some.
Rafi here. Can I jump and say something? I don't know if you can hear me.
Yes.
We can.
So I think like as Kyle said, the biggest thing as for the users is the prototyping, because now any step on the flow becomes like a line in the Python interface. It is much more readable for normal users, especially our scientific users that are not used to the JSON, to go comment a line, try to rerun now this 2 or 3 step flow. And then once they're ready to run the full production, they just uncomment the other things. And for them, the flow, the JSON is self-written. So they never touch the real Automate interface. That saves a lot of time and debugging.
And this is Jim Prine, another member of the sort of Gladier team. I'll put in my sort of favorite feature of it that Nick probably didn't have time to talk about. There's also a library of existing tools for doing some common tasks. And it's really easy to compose things. Once you've built a tool that wraps a funcX function or a functionality like transfer, it's easy to pull that from the library like you do other Python functions or Python classes, and just incorporate that into flows. So.
Thank you, everyone on the Gladier team. We appreciate the feedback. I guess one thing, last year, I think we had more flows discussion than this year. And for those that aren't familiar, I see the future of flows and funcX as being very intertwined. I think they really are very dependent on each other. Flows sort of can't do a lot of things if it can't orchestrate computation. And from a funcX perspective, we often have this requirement as part of a bigger sort of research process. It's something that needs to happen automatically when data is produced. It's something that needs to happen after another step. So I think over the coming years, you're going to see these two projects really become very, very, very integrated. And probably next year at funcX Fest, we should make sure to have a sort of maybe a flow specific session of the workshop.